Hello everyone, today we are going to see the power systems 2 unit 3 lecture 2. In this lecture 2 we are having the open end line. So till now we have seen in the last class that the travelling waves, how the travelling waves are going to be produced, how these travelling waves travels from sending end to the receiving end. So that we have seen in the last class, right. So we have also seen that there is a velocity of a transmission line or travelling wave, how much velocity it is going to be travels. So that is the travelling wave will travels towards the receiving end with a velocity of light velocity, that is 3 into 10 to the power of 8 meters per second. So with that light velocity, the velocity of the travelling wave is equal to the velocity of the light, that we have seen in the last class. So if you see the learning objectives of today's lecture, so that is first one is to understand the voltage wave on open end line. So how the behavior of the voltage wave on the open end line, and what is the behavior of the current wave on open end line. So that is what we are going to see in this lecture. Okay. So here open end line. So what is actually the open end line means? There is a sending end, that sending end is contains the voltage source, and at the receiving end we are open circuiting. So there is a receiving end, there we are going to open circuit, means we are not connecting any load onto the circuit. That means there is a long transmission line. So for that long transmission line we are not connecting any load. So consider a line with receiving end and open circuited. Receiving end open circuited. So when the switch S is closed, what happens when the switch S is closed? Normally the voltage and current waves are going to be forms and which are going to be travels towards the open end or receiving end. So at the receiving end it is open circuited, means the waves are going to be travels towards the open end with a magnitude of V and I. So when I am going to close the switch, means S is closed, means that is time t is equal to 0 plus at an instant of closing of the switch, that is t is equal to 0 plus. Then the impedance of the transmission line, at this condition is, which is having the magnitude of V, voltage wave magnitude is V and current wave magnitude is I, then the impedance becomes Z is equal to V by I you are going to get. That is what we are calling as characteristic impedance. So that also called as Z characteristic impedance or natural impedance or surge impedance, that is equal to Z is equal to under root of L by C. We have seen that in the last class, right. So here let us consider the last element of the line, that is dx. So if you see the last element of that line dx, let us consider that dx, because it is here where the wave is going to see a change in the impedance. Because why I am saying that there is a change in the impedance means, actually up to that element, the last element dx, where you are having the dx is nothing but it is a at ending of the line. So at the ending of the line means up to the open end. At the open end you are going to have the infinite amount of impedance, because it is a open circuit. There is no path to flow the voltage or current wave. There is no path to flow the voltage or current wave. That means it is a open circuited. So at that place you are going to get the change in the impedance. That means you are going to have an infinite amount of impedance at the open end. So at the open end you are having infinite amount of impedance, means that that impedance is separate or different from the characteristic impedance. This characteristic impedance is up to the line end or open end, that voltage by current value is nothing but the characteristic impedance, but this impedance, characteristic impedance, is different from the impedance which is having the infinite magnitude. So that is different, that is an impedance different from the Z, that is infinite impedance as the line is open end. Okay. Next, if you see the electromagnetic energy stored in the element of dx, that dx is there, right. So in that dx there is a infinite amount of, there is a electromagnetic energy is going to be stored. That electromagnetic energy stored is nothing but half L dx into I square. Half L dx into I square you are going to get. The electrostatic energy is also going to be stored in that element, because inductor and capacitors are going to be forms, right? Inductor and capacitors are going to be forms in the long transmission line. Then the inductor will store the electromagnetic energy and the electrostatic energy is stored in the capacitor element, right? So in that element dx there is a electrostatic energy is also stored. That electrostatic energy is given by half C dx v square, half C dx v square, isn't it? So since the current at the open ended line is 0, because there is a open, means there is no path to flow the current. So the current at the open end is 0, the electromagnetic energy is going to be vanishes, because electromagnetic energy is nothing but half L dx I square. So there is an item, there is no current to flow after the open end, right? After the open end there is no path. Then what happens? Then electromagnetic energy is going to be vanishes, half L dx I square, I is equal to 0. Then electromagnetic energy vanishes, means electromagnetic energy is 0, and that is transformed into the electrostatic energy, because the energy neither creates nor transfers, neither what we call. So here electromagnetic energy is going to be transformed from one form of energy to the another form of energy. That is, here the energy neither creates nor destroys, but it is transformed from one form of energy to the another form of energy. That is, here the energy, whatever the electromagnetic energy stores, that is going to be transferred into the electrostatic energy. So as a result, that here let us consider the change in the voltage be E, then half L dx I square, which is equal to half CV or half C dx v square. So here the electromagnetic energy which is stored in the inductor is transformed into the electrostatic energy. Then you are going to equate the two equations, that is half L dx I square is equal to half C dx v square. Then if you solve those equations, you are going to get E by I square, which is equal to L by C. So that V is nothing but change in voltage, I am considering as a E. Then you are going to get E by I whole square is equal to L by C. Then E is equal to I into Z, because E by I is equal to under root of L by C. So what is that? Under root of L by C is nothing but the characteristic impedance, that is value of the Z. Just I am substituting that E is equal to I into Z. So that is equal to the V, capital V. Okay. This means the potential of the open end is raised by V volts. That means the potential energy at the open end is raised by V volts. Therefore, the total potential of the open end, is, that is when the wave reaches the end, that is the other end, that means at the starting end. So first it is going to be travels with a voltage of V, then again it will reflect back and which will travels towards the sending end, that will reaches the sending end with an voltage of 2V, that is V plus V. Actual voltage, incident wave voltage is V value first, and then it is reflected back with a positive voltage, positive sign, that is plus V. V and plus V reflect back, that is 2V total. Total voltage is 2V. Okay. So here I am saying that there is an incident wave, reflected wave and refracted wave. What is actually the incident wave? So the wave that starts traveling over the line when the switch S is closed, that is from the sending end, when it is starts traveling when the switch S is closed, that could be considered as a incident wave. Next, reflected wave. So after the wave reaches to the open end, the rise in potential V could be considered due to a wave which is reflected back, due to the wave which is reflected at the open end. So the wave which is reflected back is known as reflected wave. the wave which is reflected back is known as reflected wave. And there is a refracted wave. What is that refracted wave? The actual voltage at the open end could be considered as a refracted or transmitted wave. That means refracted wave is equal to incident wave plus reflected wave. Incident wave plus reflected wave is nothing but a refracted wave. So these terms are very important for your exam point of view. That is, for 2 marks you are going to get these questions. Okay. Next, here for the voltage wave for an open end line, a travelling wave is reflected back with positive sign, and the coefficient of reflection is unity. And the coefficient of reflection is unity. That is V plus V, 2V, right? That is a coefficient of reflection, that is 1, that is unity. So now let us consider the current wave. So till now we have seen the voltage wave. Now consider the current wave. So as soon as the incident wave of I, which reaches the open end, the current at the open end is 0. That means there is an open circuit. There is no path to move the current towards the other, that is load. So there is an open end. That means at the open end there is no flow of current. That means the current at the open end is 0. This could be explained by saying that a current wave of I magnitude which travels back over the transmission line. So it is going to be travels back to the receiving, to the sending end side, but with a negative sign, because first wave is travels towards the open end is I, and again it is reflecting back, means minus I minus I, which gives your open end. At the open end is 0 volt. That is, current is 0 at the open end. This means for an open end line, a current wave is reflected with negative sign, and coefficient of reflection is unity. Coefficient of reflection is unity. Okay. So if you see the diagrams or explanation of this voltage and current waves, so with the time by time, that is for t is equal to 0 plus and t is equal to L, t is equal to L plus, t is equal to 2L, 2L plus, like that. As the time changes, how the behavior of the voltage wave and current wave is going to be changes, we can see in this diagram. So here first at t is equal to 0 plus, that is at the instant of switching, at t is equal to 0 plus instant of switching, then the current wave and voltage wave starts traveling, right? That is, voltage and currents are going to be starts traveling at t is equal to L, at the instant of after traveling the wave after time t and after the distance L, that is V and I, that is V and I. So after that t is equal to L plus, after that t is equal to L plus instant of time, that means after the reaching the wave at the open end, after the wave reaching the open end, it is going to be reflected back. So it is going to be reflected back with, voltage wave is going to be reflected back with positive sign, and the current wave is reflected back with negative sign. Okay, that means at that place you are going to have the 2V, and the current wave is having negative sign, right, minus I. And then after reaching 2L is nothing but after reaching to the reverse, that is at the sending end. At the sending end means it is 2V. So like that 2V, and again it is going to be moves, but the current is 0 here, and again after 2L plus distance, then what happens? Again voltage reflect back with negative sign, that is voltage is going to be reflect back with negative sign, because at any point of time the voltage is not going to be doubles at the sending end. That means whatever the 2 voltage is there, that is going to be again reflect back with a negative sign, then it will reaches towards the 3L time, that is 3 length, that is t is equal to 3L, at t is equal to 3L, that is voltage. So that voltage is going to be have V only, but the current is minus I, current is minus I, negative current. Okay. So at t is equal to 2L plus, the current is reflect back with negative sign again. So it is going to be have only minus I. Next, after t is equal to 3L plus, after t is equal to 3L plus, then again voltage wave reflect back. That reflect back of voltage wave is negative. So that negative wave is going to be have continuous towards the towards the line, then here in the current wave is also reflect back with minus I, and minus I means plus. So, plus I is going to be reflect back. So, T is equal to 4L, at T is equal to 4L time the voltage is 0 and current is 0. That means voltage and current waves are going to be becomes 0 after it is reaching the 4L. That means 4L of time it is going to be voltage and currents are going to be 0. So, this continuous rotation of the waves of this cycle is going to be rotates until the voltage wave reaches or current wave reaches towards the open end. Until it reaches the open end, the cycle is going to be repeated. Okay. So, if you see the summary of this lecture, in this we have seen a travelling wave is moving on the open end line. The voltage wave for an open end line, a travelling wave is reflected back with positive sign and coefficient of reflection is unity. The current wave for open end line, a travelling wave is reflected with negative sign and coefficient of reflection is unity. Okay. So, that is what we have seen in this lecture, and thank you everyone, thank you for listening this lecture.